Hello students, this video on ray optics and optical instruments part 8 is brought to you by VGuide TV. In this video, I am going to discuss about optical instruments, that means microscope and telescope. What is a microscope? Microscope is used to view very small objects, very small or minute organisms. So we use microscope. Very small objects. So there are two types of microscopes are there. One is called simple microscope. Simple microscope is nothing but a reading lens. It is nothing but a reading lens. So we use this lens for reading purpose. For reading purpose, I want to see the erect image. Okay, if I'm reading a book, I want to see the erect image of the letters. So here you see, I have taken a convex lens, simple convex lens. But at this case, as we are taking, your object is placed between focus and optic center. It means this is F and this is O. We know that when an object is placed between focus and optic center, what happened for the light ray? The light rays which is going parallel will go through focus, and the light ray which is going through optic center goes like this. If you extend it back, it got intersect at a point and there we get the image. Okay, this is the situation we know. So, for a simple microscope, your object is placed between focus and optic center so that we are getting a erect, virtual and an enlarged image. And this image we can get at two different points. So, I am taking the first case, the image is formed at near point. Near point means without strain, what is the minimum distance required to see an object? That is called least distance of distinct vision, and that is called D. D is 25 centimeter. It's a constant value. So first I am taking your image. This image is obtained at a point called near point. Okay, near point is D. For a lens, I know magnification equation is V by U. That is V into, I have taken this inside, 1 by U. I applied your lens formula. 1 by U, I can write it as 1 by V minus 1 by F. V by V is 1. 1 minus V by F. What is the heading I have written? Image is formed at the near point. That means this point is near point. So I am taking V as minus D. By sign convention I am doing, if V equals minus D, you will get equation for M as 1 minus 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 and minus D. It becomes plus. So 1 plus D by F is the equation for magnification when the image is formed at near point of a simple microscope. Clear? For a simple microscope, if the image is formed at near point, what is the magnification? 1 plus D by F. Next case is, I am taking your image is at infinity. Okay, image is at infinity. This we are taking in another way because we cannot use that magnification equation. If the image is at infinity, we are taking another equation for magnification, that is called the angular magnification, and we take it as with respect to angle, not with respect to distance, because we cannot take the distance over there, right? So I have drawn here two diagrams. The first diagram is, you are seeing an object with your naked eye. We are not using any instruments or any lens or something. You are just seeing the object directly. What is the angle subtended by the object to your eye? That is called theta naught. Okay. So what I am telling, the maximum angle it can subtend and can be clearly seen without a lens when it is at near point, that is at D. So we can take this as, if we want to see an object without strain, we know that it should be at least distinct vision. or at near point. So this angle I marked as theta naught, and this I am taking as the height of the object. So I am taking here h by d with respect to this triangle. So what I told, we are just seeing without any lens what is the angle subtended by our eye to the object. Okay. Then that is tan theta naught is equal to h by d, that is equal to theta naught. That is theta naught angle subtended by the object. Then when the image is at infinity means you know where is your object. Object should be at focus. That's what I drawn this diagram. So in this diagram, this is nothing but focus. When your object is at focus, where should be the image? Image should form at which point only? It won't intersect. You see, it will go like this only. So it means that it will intersect at infinity. So second diagram, what I did is, your object is at focus. Why I am taking this? Because they gave it clear, your image at infinity. So what is the angle subtended by the eye to the image? That is called theta I. So here image, you see, it is forming at infinity. So these triangles are similar triangles. So instead of taking the image which is formed at infinity, I am just taking an object only because they are similar. So this is h and this is f. So what will be theta I? Tan theta I is h by f. That also, if the theta is small, we can write it as theta I. So this magnification is theta I by theta O. H by f by h by d. H cancel. So we will get m equals d by f. So what I told, when image is at infinity, where should be your object? Focus. For that we need two diagrams. One is without any strain, you just see your object directly without any lens. That angle subtended is theta naught. Then another one we need with image, but image is formed at infinity. Instead of taking image, we are taking object. Object should be at the focus. That angle we are taking because that will be similar to the image formed at infinity. So that angle I am taking. So this ratio of theta I by theta O is called magnification. So I got the equation for magnification, m equals d by f. So what I discussed now, I discussed just now about a simple microscope. It is a reading lens. We use convex lens. And first case, they are given the condition your image is formed at near point. The image is formed at near point, your magnification is 1 plus d by f. Then if your image is formed at infinity, if the image is formed at infinity, your magnification is d by f. Okay, all the diagrams you got clear, I feel. Now next is, but with this simple microscope we can't see any minute organisms, so their magnification is less. So I use a compound microscope. In a compound microscope we are using two lenses. The lens which is near to the object is called objective, and the lens which is near to your eye is called eyepiece. What is that? For getting larger magnification, we use two lenses. One is called objective, other one is called eyepiece. By seeing the diagram, you can understand that focal length of eyepiece is greater than focal length of objective for a compound microscope. Focal length of eyepiece should be greater than focal length of objective. Another one. This objective, here is your object. I need a real image of that. I need a real image. So because of this object, I am getting a real image here. Real, inverted and a magnified image I am getting here. And this image acts as an object for the eyepiece. And we get a very big, virtual, enlarged as well as an inverted image with respect to our object we are getting. So what I want to tell, here there are two lenses. So first lens object, we get an image. First lens image act as an object for the second lens, and finally we are getting an enlarged image, virtual image. Now we take the situation. Here also the similar two cases are there. Your final image is formed at near point D. In another video I told if you use more lens, the magnification will be increased. So total magnification is MO into ME. MO, okay, I have written reverse. MO is VO by UO. ME, if you see this diagram, you can see that this and this you see, we are getting a virtual image, right? This is similar with your simple microscope equation. This is the similar like your simple microscope case. That means this one. Okay, that means they just gave it like this. That is only one difference. So this this image act as an object for the second lens, and we get a final inverted image here, right? Now I'm going to write all the terms. This is the object with respect to objective, so UO. This is the image with respect to objective, so it is called VO. And the distance from this to this eyepiece is called UE. And the distance from this to the final image is called VE. What is this? Objective distance or object distance with objective, image distance with objective, object distance with respect to eyepiece, image distance with respect to eyepiece. Clear? UO, VO, UE, VE. So what I told, the first case is your objective. That magnification I am writing simply that VO by UO. But the second, this and this, it is similar to your compound microscope case. So here no need of any derivation. You can directly write. When the final image is formed at near point means you can write MO into ME. That is VO by UO into 1 plus D by FE. That is VO by UO into 1 plus D by FE is the equation for magnification when the final image is at near point. If the final image is at infinity, we already did that. If it is at infinity, for a simple microscope we did that also. If it final image is at infinity, equation for magnification is D by F. Just writing VO by UO into D by FE. Now here if you see the diagram, you will understand a very important thing. That means what is the distance between this point from this lens to this lens? That is VO and UE. So that is called the tube length of a microscope. That is I have written as L. L equals VO plus UE. See the diagram again. We need this distance, the distance between the lens. That is VO plus UE. So we are writing L equals VO plus UE. Okay. So this is called the tube length of a microscope. Tube length of a microscope. Now if you take the final image at infinity, VO by UO into D by FE I have written directly. But there is a situation or a condition for this also. What is that condition? You know that this distance, this VO can come up to which point? If it is coming, this image is formed at the focus of the eyepiece, we get image at infinity. Right? If this distance VO is coming at focus, we get this at infinity. So this can come up to which point only? We can take that UO can come closer to FO. Okay? Because if it is at FO, we don't get an image in middle. If it is at FO, we don't get an image. Which one? If this point, if this is at FO, I don't get here. So we are taking the condition as UO can be approx to FO. Then VO can approximately equal to this, can come up to this point. So we can write VO approx to L. So I am just using, instead of VO, you are writing L. This is a condition and approximation we are giving. UO, we can write FO. So it is L by FO into D by FE. So in simple microscope, we have only one term, that is 1 plus D by FE and D by FE. But in compound microscope, as there are two lenses, we have VO by UO into 1 plus D by FE for final image at near point and L by FO into D by FE for final image at infinity. This is for a compound microscope. And this L is called, what is L? It is called the length or distance between the lenses. It is called the distance between the lenses. So when you are taking the distance between the lenses, remember you have to take the modulus only. Next is telescope. Telescope is the instrument used to view far objects, like distant objects. Here we have two types of telescopes also. So first is called refracting telescope or astronomical telescope. Just the reverse condition. It means that in this case, objective focal length should be more than eyepiece. Here also we have two lenses. As telescope we know used to view far object, we are taking the light rays coming from infinity. We get an image. This image acts as an object for the second lens and we get the final image somewhat at far. Here also, as we know, like it's an object at infinity, we are using angular magnification equation. Here how I am taking the angle, you see, this angle is called beta with I and this angle is called alpha. So I have written here, magnify when final image is at infinity, telescope is said to be normal adjustment. The magnifying power of a telescope at normal adjustment is defined as next. The ratio of angles subtended by the image at the eye as seen through a telescope to the angle subtended by the object when both object and image lie at infinity. So we are taking these two angles. One is this angle, one is this with I, that is beta, other one is with the alpha. In the alpha is angle in which object is at infinity. So just write here beta by alpha. Here also how we are taking is, I am taking this small triangle. So this I am taking this as the focal length of objective and this part you are taken as, here also a similar height we are taken here. This also we are taking here. Here we told here this is at infinity. So this should be at focus, right? So we can take the similar h here. So tan beta is nothing but h by Fe and tan alpha is nothing but h by Fo. So we can write m is equal to beta by alpha, that is h by Fe by h by Fo, that is Fo by Fe. That is your magnification equation. But for a telescope, the length is Fo plus Fe. Remember the distance between these two, we can take it as Fo plus Fe. So here you remember light rays are coming from infinity, it get intersected here. This acts as an object for eyepiece and we get the final image. Then we take two angles, that only remember, beta, alpha. Tan alpha is h by this one, that is Fo. Tan beta is h by Fe. Why we are taking this as Fe means because they told we are taking object also at infinity, image also at infinity. So this image is at infinity means this should be at the focus. Okay, so in that way we are taken. So h by Fo by Fe is the equation for magnification of a refracting telescope. The name is refracting because refraction is taking place here. But this telescope has a lot of disadvantages, so they are taken another telescope called reflecting telescope. It is also called Cassegrain. Here we have two concave mirror, two objective mirrors that are concave mirror. Light rays are coming parallel. It is hitting here, reflecting, coming back to the secondary mirror, and we are getting the final image with the help of this eyepiece. In a reflecting telescope, your objective is a mirror of large aperture. Instead of a convex lens, we use a concave spherical mirror. We use a concave spherical mirror, objective mirror. If you use this telescope, the advantages are there is no spherical aberration because lens, due to the difference in the sphericity, there will be some defect, that is called spherical aberration. So if you use mirror, there is no spherical aberration. No chromatic aberration. In lens, due to the difference in the wavelength of the light also, there are defects, that is called chromatic aberration. So spherical is due to the sphericity defect and chromatic aberration is due to the color or due to the wavelength. So these two defects are not there in mirror. So if you use reflecting telescope, there is no spherical aberration, no chromatic aberration, and easy to construct and fix the objective mirror of large aperture, and it has a high resolving power. So we can use reflecting telescope. So what I discussed is we have two types of telescope. One is refracting, other one is reflecting. Okay. So refracting telescope, your magnification equation is Fo by Fe. Length is F4 plus Fe. For a reflecting telescope means instead of a lens we are using mirror. Why we are using? Because it has no spherical and no chromatic aberration, and it is easy to construct, and also resolving power is very high. Thank you. Subscribe for more videos of class 1 to class 12 for boards, foundation, JEE and NEET. Thank you.